Hey, engineering. So we started last week with a discussion on reverse engineering, and you guys did a really good job of the first step of reverse engineering a product, which is the visual analysis of that product. Okay, so we looked at a mousetrap. You just did Iron Man's helmet the other day, and you should have an idea of what it means to visually analyze that product. Okay, we use the elements in the principles chart, and we kind of get inside the mind of the person who designed it and understand where they were, I guess, focusing their ideas when they built it. All right. So the next step in reverse engineering after you visually analyze is something called functional analysis. All right. And functional analysis is a little different. We kind of want to understand how this product from your, I'm going to use the terms inputs and outputs throughout this, but we want to sort of see an input from you does what? What do you get out of the product when you put an input into it? All right. I know I'm not explaining that really well, but let me give you kind of a visual here. Okay. So take a look at this guy. All right. Flashlight, right? Well, what's the goal of that thing, right? What's the goal of the flashlight? It's to provide some sort of, it's just to provide an unnatural form of light, right? Well, how do we make it work? And what's happening on the inside when I do provide an input? See, this is my input. My input's right here. Hear that? That's my input. What happens after that? All right. So there's a whole lot of stuff going on inside here. And you kind of got to break it down and disassemble it to understand all the different things that are going on. I mean, look at this. There's quite a bit there. And then this comes apart. And this comes apart. It's actually kind of fun to take stuff apart. Okay. So, out of just clicking that button on the bottom of that, how did I make light come through the LED in the end of the line? And that's kind of what functional analysis is sort of a deep dive into all the mechanisms that this product is made up of and how I get from point A to point Z, clicking the button and making the light turn on, okay? So we need to be able to do that, and there's an idea known as the black box in engineering, and we'll look at that here briefly, okay? So this is functional analysis, okay? And you guys did a good job of kind of defining what reverse engineering was the other day, all right? Basically kind of pulling stuff apart to understand it, how does it operate, and maybe eventually trying to make something better out of it, okay? And I'm going to kind of skip through this a little bit. And here we go. Why is reverse engineering used? Increased efficiency, reliability, make something that's maybe a little bit cheaper, something that doesn't fail. I actually went to San Antonio with Mr. Steckline for a science conference, and we actually went to a place, it was like a city of scientists. And all these buildings, they were doing different things. They were making satellites. They do their own rockets to send satellites. They work on military weapons, basically, but like not guns and ammunition and stuff like that. They were doing like lights that you would put on the sides of boats that would literally blind the opposition. Really cool stuff. Anyways, one of their facilities was dedicated to eliminating failure. And so what these scientists were doing was they were using really high-powered microscopes to look at even like razor blades. Why do razor blades dull? And so They had a whole thing dedicated to the failure of things and how to reduce that. Okay, how to make stuff last longer, right? I mean, just think of batteries and cell phone batteries and stuff like that. We want stuff to last longer. Okay. So reverse engineering tools, you're going to have to make sure you know how to use a caliper and so on. Obviously, we're not going to use an optical probe. In a really, like I mentioned in San Antonio, I'm sure they have scanners that they can use. Okay. But we've tackled visual, and now we're talking functional. All right. So functional analysis is basically, like I mentioned, this idea of inputs and outputs. And they use the example here of the toothbrush. The purpose of a toothbrush is to clean teeth and gums to prevent tooth and gum decay, obviously. Water and a cleansing paste are used in conjunction with the brush. That's the purpose of it. Now, what happens when I hit that on switch? Okay. So function, an annotated sketch with the visible components is labeled, all right? And a hypothesis is devised to describe in detail the sequential operation of function of the device using the sketch as a reference. So we sketch it out, and then we use that sketch to create basically a series of this happens, and this happens, and this happens, almost like a timeline. They use the term sequential operation. All right, so the black box model here is to put your product function here and then tell all the things that you do to put into the product and everything that you get out of the product after that input, okay? Here, let me go ahead and skip forward. So here's kind of an idea, all right? We know what the function of the toothbrush is, and these are all the inputs and what you get out of it from each one of those inputs. Okay. So that's functional analysis. Well, how does that apply to our project? Our project is the mousetrap, right? So if I get back to here. Okay, so here's my mousetrap. What's the function of this mousetrap, right? The function of the mousetrap is to catch a mouse, right, using some sort of bait. That's fine, but now what kind of inputs does it take to make this an operational item, okay? What's it going to take from me as a number of different inputs? So that's what we'll do in class, is break down the number of different things that I have to do to make that work. And we'll use that black box, method to do that, okay? Sorry, I'm putting my, my flashlight back together. All right, so that's it, okay? I just wanted to take today and introduce functional analysis.